The next bit in Module 2 is pneumatic actuators. Pneumatic actuators are the devices used for converting pressure energy of compressed air into the mechanical energy to perform useful work. In other words, actuators are used to perform the task of exerting the required force at the end of the stroke, or used to create displacement by the movement of the piston. The pressurized air from the compressed air is supplied to the reservoir. The pressurized air from the storage is supplied to pneumatic actuators to do the work. The types of pneumatic actuators, basically there are two types, that is linear actuators and rotary actuators. In the linear actuators, again, there is a single acting cylinder type. A single acting cylinder produces the work in one direction of motion, hence they are named as single acting cylinders. The compressed air pushes the piston located in the cylinder barrel, causing the desired motion. The return stroke takes place by the action of a spring. Generally, the spring is provided on the top side of the cylinder. Now, the double acting cylinder. The main parts of the double acting cylinder are piston rod, cylinder tube, and end caps. The piston rod is connected to the piston head and other end extends out of the cylinder. The piston divides the cylinder into two chambers, namely the rod end side and piston end side. The seals prevent the leakage of the oil between these two chambers. The cylindrical tube is fitted with the end caps. The pressurized oil or air enters the cylinder chamber through the ports provided in the rod and cover plate. A wipe seal is provided to prevent the leakage of the oil and entry of the contaminants into the cylinder. The combination of wiper seal, bearing, and sealing ring is called as cartridge assembly. The end caps may be attached to the tube by threaded connections. The welded connections or tie rod connections. The piston seal prevents metal to metal contact and wear of piston head and the tube. These seals are replaceable. End cushioning is also provided to prevent the impact with one end caps. Now, the rotary motors. The pneumatic motors convert compressed air to rotary motion. These motors can be utilized to prevent a smooth source of power. They are not susceptible to overload damage and can be installed for long periods of time without any heat problems. They can be started and stopped very quickly, and with the pressure regulation and metering of flow can provide infinitely variable torque and speed. Now, we are discussing the gear motors. The gear motor consisting of intermeshing gears inside a housing with one gear attached to the drive shaft. The air enters from the inlet, cause the rotation of the meshing gear due to difference in the pressure and produces torque. The air exits from the exhaust port. Gear motors tend to leak at low speed, hence are generally used for medium speed applications. Piston motors are either radial or axial and are available in the power range of 2 to 25 HP. Maximum speed is around 5000 RPM. The axial motor has axial piston which acts on a swash plate and produce rotary motion just as an axial piston hydraulic motor. The key to the radial piston motor is valving, which directs compressed air into the correct piston. The radial pistons act on the cam in sequence to produce rotary motion. Single slide vane motors are simple in construction and light in weight and are widely used. As might be anticipated, their principle of operation is the opposite of the sliding vane compressor. Like the sliding vane compressor, the vanes are forced out against housing by a centrifugal force. Small amounts of compressed air are ported to the vane slots to force the vanes against the housing of a good seal. Compressed air flows into the chambers formed by the housing and two successive vanes. Sliding vane motors will have 3 to 10 vanes. The air expands and causes the rotor to run. Air is exhausted as the leading vane passes the exhaust port. The speeds of the 3000 to 8500 RPM are typically and reversible units are available. Now, the design of hydraulic circuits. A hydraulic circuit is a group of components such as pumps, actuators, control valves, and conductors arranged to perform useful work. It gives us an idea about how these components are interconnected. There are three important considerations in designing a hydraulic circuit. First one is safety of machines and personnel in the event of power failure. Second one, performance of a given operation with minimum losses. And the third one is cost of the components used in the circuit. It is very important for the fluid power designers to have a working knowledge of components and how they operate in a circuit. Hydraulic circuits are developed through the use of graphical symbols for all components. The symbols have to conform to the ANSI specifications. Using schematic symbols as building blocks, one can construct a functional diagram showing piping arrangements and operation of any hydraulic circuit. Many circuits are used frequently in the fluid power system to perform useful functions. For example, metering circuits offer precise control of actuators speed without a lot of complicated electrics, and pump uploading and regenerative circuits make a system more energy efficient. The other circuits are designed for safety, sequencing of operations, and used for controlling force, torque, and piston. Still, other circuits may enhance the application of specific components such as pumps, motors, actuators, and filters, and airlines lubricators. The design of pneumatic circuits. A pneumatic circuit consisting of a variety of components such as compressors, reservoirs, filters, pressure regulators, lubricators, mufflers, air drivers, air dryers, actuators, control valves, and conductors arranged so that useful tasks can be performed. In a pneumatic circuit, the force delivered by a cylinder and the torque delivered by a motor are determined by the pressure levels established by the pressure regulator placed at the desired locations in the circuit. Similarly, the linear speed of the pneumatic cylinder and the rotational speed of an air motor are determined by the flow control valves placed at desired locations in the circuit. The direction of flow path is established by the proper locations of the directional control valves. After the pressurized air is spent driving actuators, it is then exhausted back into the atmosphere. The pneumatic circuits have the various functions like to control the entry and exit of compressed air in the cylinder, to use one valve to control another, and to control actuators in any other pneumatic drive devices. When analyzing or designing a pneumatic circuit, the following four important considerations must be taken into account. That is, safety of operations. This means that an operator must be protected by the use of built-in emergency stop features as well as safety interlock provisions that prevent unsafe, improper operations. Although the compressed air is often quiet, it can cause sudden movement of the machine components. The movements could injure a technician who, while troubleshooting a circuit, inadvertently open a flow control valve that controls the movement of actuator. The second one is performance of the desired function must be accomplished on a repeatable basis. Thus, the system must be relatively insensitive to adverse conditions as high ambient temperatures, humidity, and dust. Shutting down a pneumatic system due to failure or misoperation can result in the stoppage of production lines. Stoppage can result in very large costs, especially if the downtime is long due to difficulty in repairing the pneumatic system involved. The third one is efficiency of operations and costs. These are related to the design parameters. A low efficiency compressor is required more electrical power to operate, which increases the system operating costs. Although atmospheric air is free, compressed air is not. Yet, it is pneumatic system leaks. If a pneumatic system is leaking air into the atmosphere without making significant noise, it is often ignored because the air is clean. On the other hand, a hydraulic leak would be fixed immediately because it is messy and represents a safety hazard to the personnel working in the vicinity of the leak. Another cause of increased operating costs is significantly undersized components such as pipes and valves. Such components cause excessive pressure losses due to the friction. Thank you.